Good morning, students. The next topic is lexical analysis versus parsing. Okay, parsing is nothing but syntax analysis. Okay, now we'll see what is the difference or why we need to go for differentiating this lexical analysis part separate and we need to go for syntax analysis part separate over there. Okay, there are many reasons, okay, why we need to go for separating these two. Okay, out of that, we are only listing three. Okay, one is to achieve the simplicity, efficiency, and portability. Okay. Then it comes for simplicity. Okay, see, if you are combining these two phases like lexical analysis phase and syntax analysis phase, the working principle of lexical analysis is different, and when we compare it for the syntax analysis, okay, lexical analysis used to work based on non-recursive construction of the language. Okay, once it is receiving the source program, it will generate the token over. Okay, we are not coming back to the same source or we are not coming back to the same location over there. But when it comes for syntax analysis, okay, what is the job of syntax analyzer? It used to generate the parse tree over there. Okay, we know what exactly parse tree stands for. It consists of something called as a root, okay, and a leaf over there. Okay, so if you want to read the complete parse tree, we need to come back to the root, we need to go for the leaf. Okay, we call it as a recursive kind of construction. Okay, but lexical analysis will be what? Non-recursive. Okay, means once if you are generating the tokens over, we are not coming back. Okay, so we will be moving further and further. Okay, but when it comes for syntax analysis, it is working based on a non-recursive fashion over there. Okay, then efficiency. Okay, whether we can improve the efficiency or what we need to check. If you are separating these two, okay, if it is combined, okay, then obviously we are going to drop the efficiency. Okay, if you are making them separate, then easily we can achieve the efficiency over there. How? Okay, it makes simplification and optimization easier. Okay, see, source program, consider like 100 different lines of source program we are having. Okay, simply if we start generating the parse tree, it is impossible. So what we need to do, we need to convert it for the token to the parse tree over there. Okay, so if you are going to skip any one particular portion, like if you are skipping syntax analyzer or if you are going to skip lexical analyzer, we are going to miss something over there, right? Okay, so what we need to do, we need to have a contribution of both analyzer, but if you are making them separate, okay, then obviously we can get the more efficiency of it. Efficiency in the sense of what? We can execute the program faster. Okay, how? By achieving the simplification and optimization easier. Okay, then when it comes for the third one, the portability. Okay, lexical analyzers are not always machine independent. Okay, it is not always machine independent. Sometimes it will be machine dependent also. Okay, because it will be receiving the input, it will be generating the output. Okay, a lot of variations are available over there. Okay, because of that, what we make the compiler, okay, or the lexical analysis part, okay, which will be always like machine independent, also machine dependent over there. So these are the three major like the difference what we can observe. Okay, when we separate the lexical analysis and syntax analysis over there. And then next we'll go for this token, pattern, and lexems. Okay, so here you got a lot of explanation regarding tokens, what exactly patterns stand for, what exactly lexems stand for. Okay, so before I go in deep, generally I want to explain what exactly token, pattern, and lexem means. See, like we'll begin with the lexem, then that will be more clear. Okay, see, lexem means what? Source program will be received for the lexical analyzer. Okay, so lexical analyzer make a group of these streams of character. We are calling it as lexem. Okay, so that group, whatever we are having. Okay, example, consider it as if. It is what one of the keyword we are using, right? If, for, else. So these are the few keywords we are using. Okay, so if I group this if statement, if I consider this if statement as a one lexem, okay, then what will be the pattern of this if? That we need to consider. Because, okay, in line number, example, in line number 5, we have a statement called as if, open bracket, some condition we are having. Okay, if satisfied, print statement we are having. Okay, now in line number 5, we have a if statement. Okay, and also in line number 10, again we are having the same if statement. Okay, with some different condition over there. Okay, now the keyword what I am using is if over there. What is the spelling of if? If exactly. Okay, so lexem is equal to what? If. Okay, if statement. Okay, but pattern of that if will be what? I followed by f exactly. Right, so this is what we are calling it as pattern. Okay, for this if, okay, your lexical analyzer used to produce a token. A token is what? An identifier we are using to identify the if statement. Understood? See, in line number 5, we have a if statement. Okay, lexem means what? Okay, whenever we are receiving a new line, we need to make a group of those characters. Okay, so that we can generate the token separately for each and every keywords over there. Okay, now if means what? If exactly. So that is what a pattern of if exactly. Okay, whenever we encounter only if, okay, for that some predefined token should be available, okay, by your lex. Okay, for that reason we are identifying the pattern. For that if pattern we are assigning one token over there. So in further line number 10, when your compiler or when your lexical analyzer find if pattern, okay, it won't go for lexim or anything. Okay, it will directly come for the available list of token, okay, for respective pattern. Okay, it will upload that identifier for that particular position over there. Okay, this is how lexem, pattern and token used to work over there. Yeah. Okay, so regarding token we have an explanation. Okay, it is a pair consisting of a token name and an optional attribute value over there. Okay, so like token name and attribute value will be available. Then later, the token name is an abstract symbol representing a kind of lexical unit. Okay, fine. Okay, so the token will be identified, or token will be used for particular keyword sequence of input characters, okay, for identifiers. So for this particular, we are going to use the tokens over there. Then later, the token names are the input symbol that the parser processes. Okay, so this token name itself we are sending for the next level syntax analyzer. So that is what the parser, okay, where it is going to process them. Okay, then when it comes for the pattern, okay, like how it is going to appear, okay, the spelling or the gesture of that particular keyword or particular lexem, okay, we are considering it as a pattern. Regarding that we have explanation. Okay, so the lexem is nothing but a group of a character. Okay, so here we got one table which will explain this concept better way. Okay, so token information description, that is nothing but the pattern, and later sample example lexem we are having. See, we'll begin with lexem itself. Don't go for token, information and lexem. We'll begin with lexem because that lexem itself we are identifying first. Later pattern, later token we have. See, if we are having, okay, so while writing what we write, if we write, okay, what is the pattern of this particular lexem? Okay, character I comma f exactly. Okay, two characters are there, I and f we are having. So for that, the token what we can generate over here is if. Okay, so if is a token which indicates if exactly. Same for else also. See here, E will be followed by L will be followed by S will be followed by E exactly, right? The character E comma L comma S comma E exactly. So if this pattern occurs anywhere in the program, okay, we are generating a token called as ELSE. Okay, then in case of comparison also, less than we have, greater than we have, less than or equal to, greater than or equal to, okay, equal to equal to. So these are all what comparison statement. Okay, for that what we are using a key token called as comparison. Okay, we are generating a keyword called as what? Comparison. Okay, then later, in case of, see, we are using some identifiers over here, okay, like score, position, rate, okay, initial. So that was our example where while we are discussing about phases of the compiler. Okay, position is equal to initial place rate into 60. Okay, score comma position comma rate comma initial. Okay, if you find these kind of like lexem, okay, so letter followed by letter or digit. See, yeah, okay, so this is of what pattern? Letters are followed by letters itself. Okay, they are not a keyword. Okay, they can be called as identifiers over there. Okay, they can be variable. Okay, or else any other kind of information it will be. Okay, letter will be followed by letter, or else letter is followed by digit over there. Okay, example score 5, position 2. Okay, so these are all what? Letter followed by digit. Example it will be. So that we are considering it as what? The token we are considering for them will be ID exactly. Okay, we are assigning IDs over there. Then when it comes for the numbers, see as 0, 1, 10, 3.14, etc. See, any numerical constant we call it as. Okay, so for that what token we are mentioning? Numbers. Okay, if you are having number, the token we are generating it as what? Number exactly. Okay, then anything we are having in the in between the double quote. Okay, something here we are writing it as code dumped. Okay, so that is what the string we are within a double quote. Okay, so anything but surrounded by double quote, we are calling it as literal. Okay, it won't change. It won't change. Okay, like it will be fixed exactly. Literal means what? It won't change. It will be completely fixed exactly. about what exactly token, what exactly pattern, and what exactly lexem is. Okay, next, attributes of token. Now we studied what exactly token is, how token can be generated, okay, on what basis we are generating the token. Okay, like based on lexem, we are identifying some pattern. For that particular pattern, we are generating the tokens over there. Okay, for number, what we are generating; for identifiers, what we are generating; for keywords, what kind of token we are generating, we studied over there. Now, as I mentioned, okay, while explaining the phases of compiler lexical analysis, okay, like token, it consists of one more value over the token name, along with that attribute name will be mentioned over there, or attribute value will be mentioned over there. Okay, actually it is an optional. Okay, but if you are specifying that, there must be some reason, okay, for what purpose we are mentioning that. Okay, so here we are going to discuss about that attribute value. Okay, when it should be specified, what value should be specified, okay, and what is the meaning of that attribute, we'll see that. Okay, attribute of tokens. Okay, when more than one lexem can match a pattern, the subsequent phase of compiler should be provided with additional information by lexical analyzer regarding particular lexem that matches. Okay, like example, see, there was an sample expression that position is equal to initial plus rate into 60. That was our example, right? Position is equal to, while discussing the phases of compiler, we took an example that position is equal to initial plus rate into 50. Okay, so 50 or 60, 60 it was. Okay, so 60 is a constant value, forget about it. Okay, but this position, initial and rate, all three are what? The identifiers. Okay, we don't know what is the value. Okay, position value will be computed when we are knowing initial and the value of rate exactly. Okay, now see, whenever we get these kind of, you can observe over here, okay, score, position, rate and initial. So this is what the pattern we are going to get using the lexem. Okay, so we are considering it as what? Letter followed by letter or digit. Okay, we are naming only it by ID exactly. Whenever we get these kind of identifiers, okay, we are going to mention it with ID itself. But in case of position is equal to initial plus rate into 60, how many such kind of IDs we are having? Total 3 different IDs we are having. Okay, for position we are assigning one ID, for initial we are assigning one, for rate we are assigning one. Means 3 different IDs are there. They are not same. Okay, they are not same, but token we are generating it as what? ID itself, because they are identifiers. So we are generating a token as ID itself, but they are different exactly. So to identify the difference between the first ID, second ID and the third ID, we need to mention some number over here. What is that? For position, ID comma 1 we need to mention. For initial, ID comma 2 we need to mention, and for the rate we need to mention ID comma 3 exactly. That indicates, okay, like the first ID is equal to the position, second ID is equal to the initial, and third one will be equal to the rate exactly. So when we need to mention the attribute value, when you are having, okay, more than one, okay, occurrences of same kind of pattern, okay, then we need to mention the attribute value over there. Where it will be helpful? Okay, it will be helpful to upload the values of those 3 ID inside the symbol table. Okay, one represents what? One represents the first ID, that is nothing but position. Second represents, or 2 represents initial, and 3 represent rate exactly. Okay, for uploading the respective value in the symbol table, these attribute values are useful. Okay. So now see here, we got some examples over here, some attribute we have, ID comma attribute. Okay, ID comma attribute. If we only ID means what, we don't have any other identifier, we have only one, no need to mention the attribute value over there. ID comma attribute, something can be mentioned over there. ID comma 1, ID comma 2, ID comma 3, such kind we can mention over there. Okay, fine. Now some attributes we have, sample attributes, ID comma attribute, okay, bracket close, where ATTR is the position to the symbol table. Okay, like it is a pointer. Okay, it is a pointer to the symbol table exactly, where exactly it should be occurring, that particular ID that will be identified. Now assignment operator we are having. Okay, as I mentioned, position is equal to what? Position is equal to position is equal to initial plus rate into 60 we are having. So equals what we have, that we are calling it as assignment operator, right? Okay. If there is only one assignment operator you are using in that particular lexicon or in that particular statement, okay, then no need to mention any attribute value for this. Okay, only the token can be mentioned, like assignment operator. Equals are identified as assignment operator. No attribute is needed if there is only one assignment operator. If more than one assignment operators are there, yes, we need to use. Okay, next. Number comma value. Okay, see, in case of number, as I mentioned, in case of discussing that lexicon table, okay, so at last we had some numbers 0 to 10, right? Okay, 0 is also identified as num, okay, 1 also identified as num itself, okay, any kind of a number, digital number, okay, that will be identified as num itself, okay, but what is the particular value of that number? Okay, that we need to mention, right? Okay, so for that, comma value we are using. Okay, attribute position, the respective number, okay, what value we are having, that we need to mention in this particular, okay, num comma value. Okay, num means an identifier we are using to identify the number. Okay, that is what the token we are generating. What is the original value of the token? That will be specified in the attribute value. Okay, in case of value, if you are having 1, okay, token will be num, okay, value is what? 1 exactly. If you have 10, num, the token will be num as it is, okay, value will be 10 exactly. Okay, here where val is the actual value of the number, val is the actual value of number exactly. So now see here, in case of this expression, okay, E is equal to m into C into C, 2, okay, are written below. See here, okay, how it will be mentioning the IDs and how it will be mentioning the tokens and all. Okay, ID comma pointer to, here first one, that is nothing but E exactly. This first ID is nothing but E exactly. The ID, that is what the identifier we are using to identify the E, comma pointer to sim tab, okay, entry for E exactly. Okay, where it should be entered, okay, that pointer should be mentioned over here, 1 2 3 like that, okay, where it should be mentioned, okay, on what particular row of a simple table that should be entered. Later, assignment operator, see, we cannot find any equal more than once, okay, so we are not specifying any kind of attribute for this assignment operator, okay, only assignment operator we are using. That is what the token we are generating for the equals. Okay, after equal what we have, m we are having, okay, that is also considered as ID exactly, pointer to symbol table entry for m exactly. Okay, how many m's we are having? Okay, only one m. Okay, forget about it. No. Okay, then next, multiplication operator, only one we are having. Okay, so we are having multiplication operator. Then at last it is followed by what? C exactly. So ID comma pointer to sim tab entry for C exactly. Yeah. Okay, so after this expression operator we are having at last, okay, number, see here, what is that? 2 we are having, right? Number it is, okay, comma integer value 2 exactly. What is the original value of that particular number? 2 exactly. So integer value 2. So this is how the token and attribute pair can be generated over. And in case of lexical error, okay, lexical error, so we may find some error regarding like while skipping the comment lines. Okay, if a program consisting of comment line, okay, so that should be eliminated over there. Okay, during that we may face some error over there. And the interface between the symbol table and the lexical analyzer, okay, there also we may find some errors over there. Okay, so that is what the second possibility, like where we can have error in case of a lexical analysis over there. Then position of token in the file exactly. Okay, like while assigning the position of the token inside the symbol table, okay, we may be facing some errors over there. Apart from that, okay, we won't face much error in case of lexical analysis. Okay, so these are the few basic concepts regarding the lexical analyzer.